Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Fitria Amalia Putri. You can call me Fitri. I'm studying at Chemistry Department in the Maulana Malik Ibrahim State Islamic University. In this video, I will explain my summary about three topics: sampling strategy, analyte contamination, and reagent contamination. Okay, let's get started. The first is sampling strategy. What is the sampling strategy? This is sampling and preservation strategy. Sampling is collecting a certain volume of a water body to be studied, with the smallest possible amount but still able to represent and still have all the same characteristics as the water body. Sampling is divided into the following three steps. And the first step is representative sampling, and the second step is transport and preservation of samples, and the last step is sample chemistry analysis. And the next is preparation of sampling and preservation. Preparation of sampling and preservation. One is the bottles that will be used to take samples must be clean and have been rinsed with distilled water or distilled water first, then followed by the liquid that will be used to fill the water and dry. Make sure the bottle does not contain any contaminants from the previous analysis. This is because the analysis concentration is very small, so there should be no traces of contaminants from the previous analysis. And two, the same applies to sampling equipment, such as pipes, pumps, which must be clean and free from residues from the old sample, especially the growth of mold and mildew, because this fungus can absorb and reduce the thing you want. And the three, contamination from metals or sampling equipment that can dissolve in the sample must be prevented. And the four, iron, brass, bronze can dissolve in water that is acidic or alkaline, so the metal must be considered, while plastic and rubber materials can dissolve in industrial wastewater containing organic solvent or oil and gasoline. For example, the juice containers made of plastic or rubber if the sample contains organic or non-pattern materials. And the last, samples can be collected separately using a bucket, plastic or glass bottle, opened and baked, for example, with a thin ring around the neck, tied with a rope, and then put into river, canals, and wells. And this is taking samples at a certain depth. In the first, provided with a closed bottle which can be opened when it reaches the desired depth. And number two, another way is to use a kind of pump that sucks. This is because to avoid surface areas that can contain suspended solid. The three, samples from tap water can be taken with an upper beaker or a bottle to be closed, depending on the analysis plane. And then number 4, using an automatic sampler, which is a special tool for consecutive sampling. And the next, this is automatic sampler tool. Automatic sampler tool have 5 tools. And the first is suction pipe. Suction pipe, the depth of the sampling point is limited to above 5 meters below the tool. And the second tool is horse. Horse to control sampling frequency. And the third is tool samples. Tool for dividing samples into bottles for mixed samples. And the next is box isotherm. Box, exotherm, and isothermic box containing bottles of mixed samples by cooling by ordinary ice or dry ice. And the last is pump. This is disturbance that may arise during storage and transport of samples. First, cases such as O2 and CO2 can be absorbed by the sample water or can be absorbed from the sample water into the air. And the second, suspended and colonial substances can form their own flock and settle so that the sample becomes different from the state where it is taken. The third, substance and liquids that are alike can float on the surface. And some solutes can be oxidized by dissolved oxygen so that it turns into other compounds. And this is the topic, and this is a second topic. Second topic is Analyte, contamination. What is contamination? Contamination is defined as the entry of unwanted compounds into the sample during the sample pretreatment process and during analysis. Sources of contamination in samples can be from the atmosphere, operators, equipment, water, and reagents. In the first, this is a contamination from the atmosphere. That is mainly derived from particulate trace elements on the soil surface and suspended materials in the atmosphere. The simplest way to avoid atmospheric contamination of the sample is to cover the sample solution during the preparation and analysis process. And second, this is a contamination from the operators. During the analysis process, it may be a major source of contamination. This can happen directly or through the air, as in NaCl can be transferred to the sample through operator respiration. Powders, lotions, perfumes, including operators' shoes, and others can be a source of contamination. Human skin is reported to contain metals even in very low concentrations. Masks, gloves, and laboratory coats are usually worn to reduce contamination. And the third contamination is contamination from the equipment. In the example is glass in analytical chemistry means borosilicate glass such as pyrex unless otherwise specific. Contamination of the sample from the glass is usually caused by the attack of the container solution by the solution. This is have 6 example about the contamination from the equipment. The first is fused quartz silica, can be used at high temperatures and is safer from metal contamination. Contamination from materials absorbed by silica in previous use. And the two is plastic. Do you know plastic? Yes, polyethylene and polypropylene, resistant to attack. Most of the reagents used are not resistant to heat and contain additives. The three is Teflon. Teflon tetrafluoroethylene polymer can be used for temperatures up to 30 degrees Celsius and is inert to almost all analytical reagents. Number 4 is PVC, polyvinyl chloride. Most plastics are contaminated with polymers such as zinc stearate on the surface, so they need to be cleaned before use. And the 5, rubber. It is recommended not to use rubber equipment because in the trace analysis, the rubber contains several additives such as zinc oxide, antimony compounds, and PB compounds. And the last example contamination from the equipment is filter paper. Most filter paper contains a number of metals with varying content. And the last is contamination from the water. Particular attention should be paid to the purity of the water used, especially in the trace analysis, because water is used in larger quantities than the point reagents to reduce metal contamination in the water. So the water needs to be passed through an ion exchange, resin coulomb, or at least 2 distillation. And the last topic in this video is reagent contamination. What is reagent contamination? The concentration of reagents can be affected if the analyte concentration from the environment is small enough. Contamination from reagents can be grouped into 4, namely mineral acid and ammonia, inorganic solid, organic reagents, and organic solvents. The first is mineral acid. Mineral acid contains a certain amount of metals and then differentiate based on their strata based on extra pure acid, which contain very low levels of metals. Generally, very high quality reagents have a very expensive price point, while ultra pure, which contains a very low metal concentration but contains several elements, varies from one product to another. Then there is the analytical reagent grade acid, which contain the metal listed in the table such as HCl, HNO3, and the H other. And the next is ammonia. Ammonia solution in water placed in a glass bottle will be contaminated by silica, aluminum, calcium, and other elements which might be caused by attack of alkaline solution on glass. Ammonia analytical reagent can contain heavy metals in very low concentration due to glass absorption of these metals. And the next is inorganic solids. Inorganic solids, which reagent quality are usually pure enough to be used directly without initial purification, but the plain solution as a control must be made a point, for example, water solvent. Then the blank solution is point aqueous, but the solvent is non-aqueous. Then we have to make the solvent, which must be able to give absorption of UV VIS wave. Purification is usually done by crystallization or by filtration. And the next is organic reagents. Organic reagents usually contains metals that are point coordinately bound. These metals are derived from the solvent or are commonly used in the synthesis of ligands. Anorganic is very reactive to metal, so that metal around it can contaminate the sample. And the last is organic solvent. The metal content in organic solvent is relatively low. The point that must be considered is the presence of other organic compounds that are dissolved in the solvent because they can interfere with the spectrometric determination. At the preparation stage, the analyte can be loose from the sample solution due to several factors such as adsorption, volatilization, or evaporation, co-precipitation, or precipitation. And that's all. I hope my video can be useful and increase knowledge. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.